What is question? So now, previously or so far we have discussed classification with respect to the x-axis or classification with respect to the time. Now let us discuss classification of the signal with respect to the function or x of t, or classification of the signal with respect to the dependent variable. Now, in this particular case, the signal can be classified into two types. One is commonly referred to as the analog signal, and the second is commonly referred to as the digital signal. Now, previously, we were looking at the values of the signal along the time axis. Now, in this particular case, we will look at values of the signal along the y-axis or the dependent axis. Now, an analog signal corresponds to the continuous set of possible values between given interval. So just like a continuous time signal, we have to look the continuity in the values of the signal. But in this particular case, instead of time axis, we have to look the continuity in the values along the y-axis. So an analog signal has infinite number of possible values within a range or of any given intervals. So if we look at the figure, so this will make it more clear for you. So previously in a continuous time signal, we were actually looking at the time of the signal, that if the signal is continuous along the time. Now in this particular case, we are going to look at the values of the signal along the function of the signal or along the dependent variable, and we are going to check that if the signal is continuous along this particular axis or not. For example, if we look at the signal at t is equal to 0, and if we look at the signal at t is equal to 1, so you can see that the signal is continuously defined between these two intervals. And if we take any 2 points, so there can be infinite number of values in between 2 points, or infinite number of values of the signal in between 2 points. So this particular signal is continuous time as well as analog in nature. Now if we look at this particular signal, now instead of looking at the time, let's focus on the values of the signal along the y-axis. Now if you look at this particular section, so this particular section, as previously discussed, will contain infinite number of values between these 2 points. Let's suppose at this point we have a value of 1, and at this point we have a value of 2. So there are infinite number of values between 1 and 2, and all these values will be defined for a specific interval of time. So in this particular case, so this is actually a continuous time and analog signal. Similarly, this is also an analog signal, because if you look at this particular definition, the change of the function value between any 2 instants is gradual, or the value increases or decreases gradually between given instants. So if you look at this particular definition, so by this particular definition, the value of the signal, if you look at any given point, so the value will increase or decrease gradually between any 2 instants. And by gradual increase or gradual decrease means that there is no discontinuity. And this particular increase or decrease will be continuous. In fact, by continuous we means that if we take between, or if we consider the values between 2 given points, so there will be infinite number of values between 2 given points. Now in this particular case, we have an analog signal, but this is discrete time. So if you want to look or classify the signal along the values by the values along the y-axis, so it is analog in nature. Similarly, it is also analog in nature. However, if you want to classify the signal on the basis of the time, so it is continuous time, and in this particular case it is discrete time. So we have a signal which is analog as well as continuous time, and we have a signal which is analog as well as discrete time. Now this is actually the output of a sampling process. So we'll be discussing it inshallah. Now, another type of a signal is commonly referred to as the digital signal. Now, unlike analog signal in which we actually check for continuity of a signal, in digital signal, we actually look at the discrete nature of the signal or the discrete set of values in the signal along the y-axis. Now, if you look at this particular section, here we have a value of, let's suppose if we call it a value of 3 in this particular case. So in this particular case, a signal has a value between 0 and 1. Now there is an abrupt change in the value, and this particular point, there is an abrupt change in the value, and the value changes from 3 to 4 at t is equal to 1. Similarly, then the value remains constant, and then there is an abrupt change in the value, and the value changes from 4 to 2, let's suppose, at t is equal to 2. So, hence the definition, a digital signal is actually that type of a signal which uses a discrete set of values to represent the function. As we previously mentioned, that what are discrete set of values? So discrete set of values are actually those values which are not continuous in nature, or which are non-fractional values, or which are pure integer values. So if you look at this particular point, so we are actually using integer values to represent the transitions in the signal from one point to another point. Or another definition, digital signals have finite set of possible values along the y-axis. So if you look at this particular instant, if you look at these 2 points at t is equal to 0 and t is equal to 1, so the value of the signal remains same. That is, the signal has a value of 3 along the y-axis. Similarly, if you look at this particular instant between 1 and 2, so a signal has a value of 4 over all the interval. Similarly, if we consider the values of the signal between different intervals, so we can see that the signal is maintaining a same value throughout the given interval. So there is a finite set of possible values, and most probably a signal will have a single value between any 2 given intervals. Unlike analog signal, in which a signal contains infinite number of values between any given intervals. Now, so if we consider this signal with respect to time, so it is continuous time in nature. However, if we consider this signal with respect to the value of the function, so it is digital in nature. So it is a digital continuous time signal.